Hi everyone. Today I will show you guys how to use the Proforma for calculating meridian passage questions. So this is what a Proforma looks like. So what is a Proforma? A Proforma means that you don't have to necessarily write down whatever is written on the Proforma here. All you have to do is just basically fill in the figures and the numbers, so it saves you time. So in many places we use this in the exam to save students time. All right, so let's get started with filling the Proforma for a meridian passage question. So what is the question we'll be solving today? So the question is that it is 27th of October, right? It is the 27th of October 2004, and you have been given the DR position, or the dead reckoning position, is 49 degrees 55 minutes north and 150 degrees west. The sextant meridian altitude of the sun's lower limb was 27 degrees 19 minutes. So here you have to make a note of that this is a sun, is a celestial body, and it's the lower limb of the sun. So these are the details that will come in handy later on when you're filling the Proforma. Other than that, your index error is nil. So there is no index error of the sextant, and the height of I was 10.5 meters. All right. So there are two things you have to find out. Firstly, you have to find the latitude. All right, ship's latitude. And so you might think the latitude is given. So the latitude that is given to you in the question is a DR latitude. It's a dead reckoning latitude. That means that it is not the accurately known latitude. This latitude is based on the last known position. So that's why you have to calculate what we call is the observed latitude. That is the more accurate latitude. And you will see there will be a difference between the observed latitude that you find out using the meridian passage and the latitude that is given to you in the question. All right, because the one that you find out is more accurate, provided of course that the sextant site that you took was accurate as well. You also have to calculate the ship's time of meridian passage. So there are two things you have to find out. All right, so ship's time of meridian passage and the latitude. So we start with finding the ship's time of meridian passage. So if I go back to the Proforma, and you will see in the Proforma here, the first thing we do is we fill up the LMT meridian passage. So what you see here is LMT meridian passage. All right, so let me just use this pen here. So LMT meridian passage. LMT meridian passage stands for local mean time of meridian passage. Now this is something you have to get from the nautical almanac. So you get it from the almanac. All right, so you have to remember that. So you have to get it from the almanac, and what I'll do is I'll erase it. I'll write the note on the side here. So from the almanac you have to get the LMT meridian passage. So let's see how to do that. So what we do, we'll go to the 2004 nautical almanac. All right, so I have the 2004 nautical almanac here with me, and this is 27th of October. So right at the top you can see I have the date given to me as 27th of October. All right, sorry about that. And then what we'll do is so I'll just zoom in to show you. So this is 27th of October 2004, right? So, and then I'll zoom out again, and then so that I can use my pen. And then what I'll do is I will go to the corner. So in your almanac, of course, if you're using a book, you will see on the right hand side, right at the bottom right hand corner, you will have the sun's meridian passage time given to you. All right, so the sun's meridian passage time. So this is the sun, right, in the bottom right hand corner, and this is the meridian passage time. Now this is given for 27th of October as well, and the time given to us for meridian passage is 11:44. Now all these times are in local mean time. So this is local mean time, LMT. All right, the rest of the times in the almanac, not the rest of the time, but the time we normally use to get our GHA and all that is GMT, but this is the time given to us in LMT. All right, so if I show you here, so if I zoom out, and you will see these times here on the ship, on the side of the almanac, all these times, this time here, this is all GMT, but the meridian passage time is given to us in LMT, that's local mean time. All right, so this is where we get the time from. So if I go back to my Proforma, So in the proforma here, what I will write is the date is 27th of October. All right. So the date is 27th, and I will write the time here 11 hours 44 minutes. All right. Over here, I can fill up the proforma with the latitude and longitude given. So I have latitude 49 degrees and 55 minutes north given to me in the question, and the longitude given to me in the question is 150 degrees 00 minutes west. All right. So the next thing I fill in my proforma is the longitude in time, which is east or west depending on the longitude. So of course here the longitude is west, so I will highlight west. I can cut out east. And how do I find my longitude in time, which is also known as LIT? So this is LIT. How do I find my LIT? So LIT is nothing but longitude divided by 15. All right, so that is in hours. So LIT or longitude in time is longitude divided by 15. So in this case, of course, it's 150 degrees 00 minutes west divided by 15, which will give you the time in hours. So exactly 10 hours. All right, if there was anything in minutes and seconds, then you will note down minutes and second as well. Just here that it is 150 divided by 15, which is exactly 10 hours. So you will write 10 hours 00 minutes 00 seconds. Like I said, if you ever get minutes and seconds in longitude and time, you have to write the minutes and seconds as well. All right, you have to write the exact longitude and time that you get. So what I'll do, I'll write here 10 hours 00 minutes. So there is no seconds here anyway, of course. So the rule of thumb here, then the next thing I have to write is UT or GMT. I can also call it GMT here. All right, so I can write the GMT time. So how do I get GMT time? So the rule of thumb is that if my LIT is west, my GMT is the best. All right, LIT west, GMT best. What does that mean? Is that if my LIT or longitude time is west, my GMT will be more than LMT. So LIT west, GMT is the best. LIT east, GMT will be least. So LIT west, GMT is the best. So I will add it to make it more than LMT. All right, so what do I do here? So date is still the same. If I add 10 hours to 11 o'clock in the morning on 27th, and this becomes 2144. All right, if on adding 10 hours the date changed, then I would change the date. But here its LMT is 27th, 11 o'clock in the morning, and then I added 10 hours to it. It became 27th, 2100 hours in the evening of 27th. All right, so if it became more than 24, I would change the GMT date in this case. Right, and then I have my zone that I will use. So I can what I can write here is zone. And what is zone depending on? So the zone depends on the LIT, except that it's a whole number. So in case if your LIT was 9 hours 56 minutes, then the zone would be plus 10. And if your LIT was, let's say, 9 hours 29 minutes, less than 30 minutes, all right, this is your LIT, then your zone would be, in this case, of course, 9, not 10. All right, so I will not say plus because it's west longitude. If you have seen my other videos on celestial navigation, you know that zone west is actually -9, but when we compare GMT to LMT, so here we are comparing LMT to GMT. So anyhow, when the LIT is 9 hours 29 minutes, the zone would be 9. If the LIT was more than 30 minutes, so if the LIT is 9 hours 37 minutes, the zone would be 10. All right, now in this case, of course, the LIT is 10, so the zone would be 10. All right, so is that simple? So here again, but zone is always a whole number, a positive whole number. It is never in minutes and seconds. It's a positive whole number. All right, so here we have to write the zone. All right, so the zone is 10 hours. Now because it's west longitude, whenever it's west longitude, the zone is always negative. If it's east longitude, the zone is always positive. That's because the time on the eastern hemisphere is always more than the GMT. So we add to the GMT time to get the local time. But the time on the west is always running behind GMT. All right, the time on the west is always less than GMT. So we always subtract from the GMT to get the ship's time on the west longitude. So we will subtract 10 hours again, and the time we get is again 11:44. And is it the same day? Yes, it's the same day, 27th of October. All right, this is how we fill the first part. So if you have to calculate the ship's time of meridian passage, well, the answer is ship's time is 27th of October, 11:44. However, for the rest of the question, I will change the color of the pen here. You will choose the GMT time for the rest of the question, all right? Because the GMT time is the time used in nautical almanacs. So make sure that you don't get confused. So if the question is asking you calculate the ship's time of meridian passage, your answer will be, of course, 27th of October, 11:44. But for solving the rest of the question, for going into the almanac, you have to use the GMT time, and that's I'll show you that. All right, so anyhow, keep going. Let's get the declination now. So the declination I have to get is for the GMT time. This is for the GMT time. All right, this is the declination. So we have to go to 27th of October, and for 2100 hours and 44 minutes, I will get the GMT, the declination. All right, so let's go back to the nautical almanac here. All right, so here we have 27th of October. All right, 27th of October is here. Let me see, let me zoom it for you guys so that you guys don't get confused. So 27th of October is here, and we need for 2100 hours, right? And for sun. So you can see that the date of 27th of October is the first day on the nautical almanac page. It's the first day, but I don't need to use these columns. I need to use the column of the sun, this column here, because my GHA and declination is given here, right? So my declination is in this column here. This is my declination. So this is the one I will use, and my 2100 hours GMT time is here. This is 21, and I need it for 21:44. So I have to see whether my declination is increasing from 21 going into 22 hours. All right, so let me zoom it in for you, because I can't show you both the things together. So you have to not only see the declination of the sun for 2100 hours, but you also have to see whether going from 21 to 2200 hours, your declination will be increasing or decreasing, because you need the declination for 21:44. So you have to see the pattern, you have to observe the pattern here, right? So I'll zoom out again so that you guys can see the screen and the numbers at the same time. So what do I need to do is I will go into 2100 hours. So what is the declination for 2100 hours is one here. All right, so this is 13 degrees 07 minutes south. All right, 13 degrees 07 minutes south is for 2100 hours. So what I will do is I'll go back to the almanac and I will write that there. But before I do that, I want to show you some few more things. All right, now this is the first thing you note down. For 2100 hours, the declination is 13 degrees 7 minutes south. Please note it down. The next thing I'm going to note down is the D value at the bottom. This is the D value. D is 0.8. Note this down as well. All right, just write down D 0.8 as well. I'll show you where to fill it in the Proforma later on. I want to show you a few things at the same time so that we don't have to go back and forth. Also notice what is happening to the declination going from 21 to 22 hours. So from 21 going to 22 hours, you can see the declination is increasing. From 13 degrees 7 minutes south, it's becoming, let me zoom it in for you, 13 degrees 7.9 minutes. Right, so the declination you can see is increasing from going from 21 to 2144 or 21 to 2200. The declination is increasing. So that is something you have to make a note of as well. All right, so I will zoom out again, and then what I'll do is I'll have to go to the increments page for 44 minutes. Remember that I need my declination for 21:44. So I will go to the increments page at the back for 44 minutes. And here I have kind of highlighted what I want to find out here before. So you have 44 minutes at the top. You can see written there 44 minutes. Yes, 44 and 45 is on the same page, but we need it for 44 minutes and 0 seconds. And you can see that the V correction value or D correction value is in the same column. This column here. This is the column. All right, so let me erase it and start from fresh. So if I want to find out the correction value for a D value of 0.8. Remember 0.8 at the bottom of the previous page. So we take the 0.8, come here, and next to 0.8 we get the correction value. What is the correction value? It's 0.6. All right, so let me zoom it in again. So for 0.8, the correction value is 0.6. We don't write 0.8, but we'll write 0.6. So these are few things you have to make a note of. All right, I've discussed all this in my other videos as well, but today I want to show you how to fill the proforma. That is my main focus here. So let's go back to the proforma and show you where the figures are to be filled. All right, so not here. So this is the question, of course. So what I'll do is I'll go back to the proforma, and then I'll show you where to fill these numbers. So the declination, the first declination is for 2100 hours. Remember that. So 2100 hours, the declination was 13 degrees and 07 minutes south, right? Then the D value was 0.8. This is where you write 0.8. Now, as you know, your declination is increasing from 2100 hours to 2200 hours. It's increasing, right? So, and the declination is south. I don't need this. So what will I do with the D correction value? I will add it because my declination is increasing, going from 21 to 2200 hours. And this is where I will write 0.6 minutes that I got, the correction value that I got from the increments page of 44 minutes. So my final declination is 13 degrees 07.6 minutes south for 2100 hours 44 minutes. All right, so this is the second part of the proforma. Now let's fill up the rest of the proforma. Now the sextant altitude given to you in the question of the sun is 27 degrees 19 minutes. This is given to you in the question. The index error is given as nil, so there is nothing to write in the index error. So your observed altitude becomes your same as in sextant altitude in this case. If you had an index error, if it was on the arc, you would subtract. If it was off the arc, you would add it. In this case, of course, your index error is nil. So you leave it alone. All right. Otherwise, you will write the index error. The next thing we have to write is dip. Now this dip is calculated for a height of I. Your height of I given to you is 10.5 meters. Is that right? Your height of I is in the question. So the height of I given to you in the question is 10.5 meters. So for a dip of 10.5 meters, let's go and see where we can find out the height of I from. All right, so I have to go back to the almanacs page, and in the almanac page, so I have to go towards the beginning of the almanac, and this is the electronic almanac. So for me, this is given towards the end, but for you guys, it will be given towards the beginning of the almanac itself. All right, so let's erase this. So we have to find the height of I, which is here dip. So dip correction for height of I, and this column is given in meters, and I have to find it for 10.5 meters. Now 10.5 lies between, let me zoom in, 10.5 lies between 10.3 and 10.6. All right, no interpolation required. So 10.5 will lie between these two values. What is the correction? Minus 5.7. All right, so this is the correction I will take, and I will go back to the proforma, and I will write that in the proforma of minus 5.7. Minus, so remember that it's all height of I correction is always negative. All right, never positive. So minus 5.7. So the apparent altitude becomes 27 degrees 13.3 minutes. All right, so 27 degrees 30. Then next you have to find is the total correction. Now before you go and find the total correction, you have to remember two things. All right, total correction, you have to first remember the month. So the month was October in the question. And the second thing you have to remember is it the lower limb or the upper limb? Now it was the lower limb. So I will use the lower limb. So all this is given to us in the question. Sun's lower limb, month of October. So these are the things you have to remember. So after having remembered this, and you have to remember the apparent altitude value, which is 2713.3, you go back to the same page where you got your height of I from. All right, you go back to the same page. And here you can see the total correction is given in this column here. For a sun is given here. So if it's October to March, you go in this column. If it's April to September, you go in the next column. For us, it's October to March, so we'll go in this column here. The apparent altitude value is 27 degrees 13.3. So we go down this column here. and because it's the lower limb, I will go down this column here. So lower limb corrections are always positive, whereas upper limb, which is next to it, is always negative. So for 27 degrees 13.3, again no interpolation required. If I zoom in, let me zoom in for you, it will be somewhere here, correct? And the correction will be 27. No, it's not here, it's above there, so it's not there. Sorry guys, I need to highlight this correctly. 2713.3 I want. So 2713.3 will be somewhere here, and you need plus 14.4, correct? That's the correction. So I'll zoom out again, go back to the almanac, go back to the Proforma and fill that value there. Why is this coming up? So these are the Proformas I'll choose later on for you guys and show that to you as well. Why did I lose the Proforma? Here you go. All right, so this is the Proforma. So I'll come back here. Total correction is plus 14.4. When I add it, you get 27 degrees 27.7 minutes. All right, now here it says name it same as azimuth. What does that mean? So you have to see where is the sun bearing from you, the observer, in the celestial sphere. To find that out, it's very easy. You have to basically compare your latitude, that is your dr latitude, with your sun's declination. Alright, so if the dr latitude is not given to you, some other hint will be given to you, like the sun was bearing south of the observer, or the sun had a south azimuth, something like that. That will give you a hint of that the sun is south or north of you. Alright, otherwise you have to compare your dr lat with the sun's declination. So you draw a vertical line, and the first thing you do is draw Q anywhere you want. Q is what? Q is your equinoctial. It's your celestial equator. I call it celestial equator or equinoctial. Not I call it, but that's what it's called. Q is an internationally renowned symbol. Alright, so that is your reference point. Celestial equator is Q. Now what's your dr latitude? It's 49 degrees 55 minutes north. So I will draw it north of the equator. Alright, so this becomes your latitude, dr latitude. So, and I will call this a Z. Z is observer zenith. This is where you are in the celestial sphere. And then where is your declination? Your declination is 13 degrees 7.6 minutes south. So that is the sun's declination. So the sun will go south of the equinoctial. Right? So the sun is south of the equinoctial, and I call it X. This is where the sun is, celestial body, and this is you as the observer. So where is the sun bearing from me? It's bearing south of me. It's south of me, right? So I will call this true altitude south. Then it says true zenith distance. True zenith distance is obtained by subtracting the true altitude from 90 degrees. So 90 degrees minus true altitude will give you the true zenith distance. 90 degrees minus true altitude gives you the true zenith distance. So in this case, 90 minus 27 degrees 27.7 minutes will be 62 degrees 32.3 minutes, and you have to name it again. How do you name it? You name it opposite to altitude. You named your altitude south, so you'll name it north. Alright, and then write down your declination as you got from the almanac, 13 degrees 7.6 minutes, and it will be south. And then the rule is given here. If it's same names, if both are north, both are south, you will add them. If they are different names, you will subtract them. Here they are different names, one is north, the other is south, so I will subtract them. And what do I get? I get 49 degrees 24.7 minutes. And how do I name my latitude? Retain name of larger, of above. So which is larger of the above? The true zenith distance, which is named north, is larger, so I will name it north. And that is my final answer. So you can see my dr latitude was 49 degrees 55 minutes, whereas my observed latitude based on the observation of the sun as a celestial body is 49 degrees 24.7 minutes north. Now if you ask me that, Sam, if that latitude was not accurate, why did we use it to name our true altitude south? Because it gives you an idea. So the DR positions used to give us a fair idea of where we are, but it would not be very accurate. Now those are the days when the GPS was not considered very accurate, or there was no GPS and people would estimate their positions. All right, so we are talking about those days. Of course, these days GPSs are very accurate, so all this doesn't hold true, but it's a good way to check your position on the ship as well. All right, so ideally, of course, you have to be very good with the sextant so that you can get accurate latitudes or accurate longitudes at sea. So anyhow, today's video was on teaching you guys how to fill the proforma. If you have proformas like this, I am going to make videos on filling the proformas for compass error, intercept as well, and I will show them how to fill it. I will give you tips on how to fill it for the star or the moon or the planets as well. It's pretty much the same thing. It's just that you have to find some extra values and fill it in the proforma. But I hope you liked this video. It was useful for you guys. These days increasingly we are using proformas in examinations in colleges, so this is beneficial for you guys. So let me know what you thought about this video, guys, and I'll see you soon with more videos on the usage of proforma for celestial navigation calculations. Keep watching, guys. Thank you for supporting the channel, and I look forward to seeing you again with my next video.